All right, section 12.5, derivative of log functions. We get a couple of rules, actually 3 rules. Derivative of log base A of x. You should remember those logarithms from some math course at some point, either college algebra or trig or something, pre-cal hopefully. It's 1 over ln a being the base of the logarithmic thing, x. Okay, we're not going to see that one as much. You might have one problem, but we're not going to see that as much. This one you will see a lot. The derivative of ln x is 1 over x. Okay, 1 over x. And the derivative of ln u is 1 over u times the derivative of u, or u prime. So if you have ln of 3x squared, you're going to have to take the derivative of that argument as well, just like we did with the e to the x. If it's anything other than x, you have to take the derivative of that part and multiply it. So let's look at some examples. Okay. If we can get up here, let's do this. Okay. The derivative of ln 6x. Okay. So it's 1 over whatever you're taking the ln of, 1 over 6x, times the derivative of 6x, which is 6. And when you multiply those, what happens? The 6's cancel out and you end up with 1 over x. That was good in the back there. Good girls. Awesome. So somebody said, well, is it always 1 over x? Somebody asked me that once, and it's not, but if it's just one number in front of the x, yes, those are going to cancel out, and it'll just be 1 over x. All right, look at the next example. ln of x squared plus 1. You put 1 over the x squared plus 1, and then multiply it by the derivative of x squared plus 1, which is 2x. The 2x goes on top. Doesn't cancel out or anything, so you end up with 2x over x squared plus 1. Okay. This is all coming back, Taylor. Waking up to it. Okay. All right. This example is the log base A of something. Remember, it's 1 over ln, whatever the base was, that was 2. There's the argument, times, and then you take the derivative of what's in parentheses. So that'll be 6x minus 4. The 6x minus 4 goes on top. All right. Questions? Anybody about those examples? It's just one quick example for each kind, and then I think we're going to go look at the problems. Yes, sir.
The answer on the denominator is still ln base 2 or just ln 2?
It's ln2, not ln base 2. Yeah, it's just ln2. If you look back at the rule, it's right there. Okay. Sometimes you can't tell with the way I write, so it's a good question. It's always good to ask. All right. Let's go to problems. All right. We start out with ln of 16x. So the derivative of that is 1 over 16x times the derivative of 16x, which is 16. The 16's cancel out, and what do we have? 1 over x. Okay. All right, then we have ln of 2 minus 7x. Always just write it as 1 over 2 minus 7x times, what's the derivative of this thing? Negative 7. Okay, the derivative of this whole expression is negative 7. So, you know, if you think about it, you think, oh, well, that's negative 7 over 2 minus 7x. MATLAB doesn't like the negative on the top, so put it out in the front and then do your fraction. Again, this would be fine for me on a test, but for MATLAB, I'm just giving you a heads up, they're going to want the negative out front. Okay. All right, we get one with a radical. Okay. Y equals ln of the square root of x plus 1. You always want to rewrite it. So rewrite it with fractional exponents. Ln x plus 1 to the 1/2. And when we get ready to start that, it's 1 over x plus 1 to the 1/2 times, now we've got to take the derivative of this thing. What's the derivative of x plus 1 to the 1/2? One half in the front. And then if there was anything other than x, we'd be multiplying by the derivative of that, but it's 1, so it doesn't matter. Okay? So everybody's good? All right. Now, to fix that, clean it a little bit. The only thing on the top is a 1. Does everybody see that? Okay. So we've got a 1 over, we've got a 2 on the bottom, and then we've got x plus 1 to the 1/2. This guy's on the bottom because it was a negative exponent. Now, what else can I do? When you multiply expressions, what do you do with the exponents? Add them. So 1/2 plus 1/2 is 1. So we ultimately have 1 over 2 times x plus 1.
Do you write that as 2x plus 2?
I think they want it like that. I mean, like I said, you know, 2x plus 2 is certainly okay, but if you're simplifying, you could leave it like that. Yeah, yeah. I think because of the way we were working the problem down, then it just stayed like that. But I think that's what they want on MATLAB. Okay. All right. Ready for number 4? And I think while I'm thinking about it, number 6, I believe, is omitted. I'm not for sure. Yeah, number 6 is omitted. So go ahead and maybe mark that on your paper. All right. On this one, we'll start out, we'll do 1 over, I guess I can move up a little bit, 7x cubed plus 2x to the 7/3 times, now I've got to take the derivative of that thing, so that is 7/3 times this to the what? 4/3 times the derivative of what's inside, which is what? 21x squared plus 2. Okay. Can y'all see that on the back? Is that big enough, the writing? That's okay. Okay. All right. So again, let's take what's on the top and put it on the top, and what's on the bottom, let's put it on the bottom. So on the top, it looks like we have a 7. And we have this thing. And we have this. And on the bottom, we have 3. Like that. Since this is all being multiplied and this is all being multiplied, we can do some canceling if possible. If it were being added or subtracted, we couldn't do that. These are the same base, just different exponents. So if you're dividing, same base, what do you do with the exponents? Subtract them. So I could say this is 7 times this raised to the 4/3 minus 7/3 times 21x squared plus 2 all over 3. And that's going to help me figure out what I'm doing. What do you get when you have 4/3 minus 7/3? -1, because it's -3/3. So -1 tells me where does that thing go back to? The bottom, but it doesn't have any fractional exponent anymore. So I have 7 times this thing's left over 3 times that thing. And then Math Lab, you know, just out of the blue, they want you to factor something out on the bottom. What could you factor out? X. So that's the only thing left to do. You would have eventually figured that out when you got it wrong the first time, but now you have a heads up, so you will be good. Yes, thank you. I like to get all those things fixed before I publish these as PDFs because it's really aggravating to do it wrong and then have to go back and fix it. Anything else? Any other question on that one? Okay. All right, the last one gets a little long, so let's do this. What do you notice about it? Whoa. What do you notice about it? What is it? Quotient. So we've got to think about using the quotient rule. It's not a product because this is just the ln of an expression. If there had been an x over here, like 4x ln stuff, then it would be a product. But you don't have two separate things. Okay, let's write out a roadmap. Get this down a little bit. Okay, so y prime is equal to x squared times the derivative of the top, which is 4 ln x plus 3, minus 4 ln x plus 3 times the derivative, that's a 2, of x squared, all over x squared squared. The other question I would ask, is red easier to see or blue? Should I change back to blue? Can you see the red okay? I just aim to please, so I want you to be able to see it. All right, so now we got to take the derivative 2 places, so that would be our next step. So that's x squared times, what is the derivative of this thing? Well, what's the derivative of ln of anything? 1 over that, and then you're multiplying by 4. So 4 over x plus 3. And you would multiply by the derivative of that, but it's 1, so we don't even need to worry about that. Okay? Minus 4 ln x plus 3 times what? 2x over x to the 4th. Okay, I'm going to clean it up a little bit more and have 4x squared over x plus 3 minus this thing. I think I can, what can I do here? Can I do 8x ln x plus 3? Yeah. Over x to the 4th. This just becomes algebra. I mean, that's all we're doing here. It's cleaning up. Okay, this isn't very clean. It's got a fraction in the top. Oh, I was looking up here. That sounded very close, Taylor. I was thinking that was right here. Okay, that'll wake you up. All right. Where am I? Okay. Let's multiply every piece of this by x plus 3 over x plus 3. I'm going to write that here. Every piece by x plus 3 over x plus 3. When I do that here to this piece, what am I left with? Well, actually, I'm multiplying, I said that perhaps wrong. I'm multiplying the top by x plus 3 and the bottom by x plus 3. So if I multiply by x plus 3 here, say I put x plus 3 here, what happens? Cancels, and I'm left with 4x squared. Let's go back to bed. So I have 4x squared minus 8x x plus 3 ln. There will be a method to the madness here. Hang on. Over x to the 4th times x plus 3. Okay? So we've gotten rid of the fraction in the top. And so now we're going to do a little factoring. We're going to factor out x. We're going to factor out x. If I take x out of this expression here, what am I left with? 4x minus 8 is x plus 3 times ln of x plus 3. This is an ugly problem. What else can I do there? Now, what's the one thing that I could do?
Can you remove x plus 3 from the top and bottom?
You should be able to. I'm thinking that we're going to, they leave that. They leave that. But can we take out this? Because they end up, the answer that they have is 4x minus 8, not in parentheses, then x plus 3 ln x plus 3 over x cubed, not x, yes, x cubed, and then this in parentheses. I would get rid of the other, but they didn't. Okay? So, when you're working a problem like that, like this one, you're going to want to follow that format. And you're going to, yes, sir?
Wouldn't the x plus 3?
That's what he was asking, and I was saying, yes, it could. And I would, but what I'm telling you is that MATLAB, they don't. So that's why we're going to leave it like that. Okay. All right, any questions on that one? Okay. No, I don't want that. Get this going.